In this chapter, we're going to look about testing hypotheses about proportions. So first of all, a hypothesis is a claim or a statement about an attribute of a population. For example, if I think about all of our community college students that transfer to a university, maybe it's the case that if we look at past records, like look at last year's records of students that directly transferred, let's say fictitiously that 50% of them transferred. Okay, since this is a claim about our population, we use the P to represent the population proportion. So I would have P equals 0.5 as my claim. Now, the null hypothesis is a statement that there is nothing happening. So we would expect this year to be no different. We'd expect 50% to transfer as well. So we'd use H with a subscript of 0 to indicate our null hypothesis is the population proportion is going to stay at 0.5. Now, the alternative hypothesis is a statement that there's some change that takes place. Maybe I started a new advertising campaign, and because I did, I want to see if it had an effect and caused more people to transfer. So I would say P is bigger than 0.5 would be my alternative hypothesis. I want to know, did my advertising campaign work? Are now there more community college students transferring to the university than previously? Notice that this is the correct way I would write out my null and alternative hypothesis, the H with the appropriate subscript followed by a comma, then my variable that I'm dealing with. In this case, it's a population proportion, so we use P. And then the statement equals a value bigger than whatever we're hypothesizing. So a one-tailed test is where we're hypothesizing a direction. That's what we did right here. Because I had the bigger than 0.5, I'm hypothesizing an increase. So it's actually a right tail, whereas this one highlights a left tail. Now, a two-tailed test means that I might have a change in either direction. For a two-tailed test, the way I would write that alternative hypothesis is P does not equal whatever my value is. In this case, it was 0.5. Then that would be a two-tailed test. When hypothesis testing, we're answering the question, if the null hypothesis is true, what's the probability of observing sample data like that we obtain from our sample? Remember, this is a sampling distribution. It should be centered at whatever my population proportion is, P. So most of my samples will fall in this region, in the middle. So if I get a really weird sample, and that's what we're denoting here with the red, where are we calling it really weird? If I get a sample in that region, it would make more sense for me to think things have changed than that I just got a weird sample off the sampling distribution. Though it is possible, I just simply did. So we either reject the null hypothesis or we fail to reject the null hypothesis. If I get a value in this region, I would fail to reject the null hypothesis for any of these values if I landed a value that was anywhere in the gray. The red is what's indicating my reject region, where we would reject the null hypothesis if we ended up with a sample over here or here. What does rejecting the null hypothesis means? I'm rejecting this statement. I no longer believe it's the case that 50% of students transfer. I have reason to believe that it's otherwise. That's what our hypothesis test is doing. So the test statistic is a data summary that we use to evaluate the two hypotheses. For the case of proportions, we're going to be using a z-value. And then the p-value is the probability of getting our test result or more extreme. So for example, if I end up with a sample over here, I'm looking at all the value of getting a sample bigger than that value or less than if it's two-tailed, or just one direction if it's one-tailed. But it would include any sample that would be weirder than the one that we got in our sample. The level of significance is the predetermined probability cutoff we use. Alpha is our level of significance. Alpha is where we denote the red. So for a hypothesis test, I'm saying the alpha is how much probability I would classify as being weird. So all my alpha would be over here. For a two-tailed test, it would be divided in half on each side. So alpha over 2 would go on each side. So there are three possible choices for our hypotheses. My null hypothesis is basically always going to be an equal to value, okay? So here and here we wrote it to be the opposite of the alternative, but you could just write equal to on all three of these. Now, the two-tailed, this is the two-tailed, which is this guy right here. This is the does not equal statement, and then both of these are one-tailed. They're just different directions. This is the less than, and this is the bigger than. So all of our alpha value is concentrated here, and it's split in half for a two-tailed. And the test statistic, the critical value that we look at for the z, so not the test statistic, sorry, the critical z value is the one that marks off. Now, what we'll do is we'll actually calculate the z for our sample, and if that z value, and that z is our test statistic, if the z value is anywhere over here, then I would fail to reject in this region. But if the z value is over here, then we would reject the null hypothesis. So this is my reject region. Now, an equivalent to looking at the z and comparing it to the z alpha, either bigger than or less than, is to compare the probability to the alpha. If my probability is less than alpha, I'm inside this region. If the probability is bigger than alpha, I'm over here. So the same is true if I'm two-tailed. I'll have two critical z's, one on each side. My fail to reject regions in the middle. So if I end up with a z value in here, then I fail to reject, and my probability will be bigger than the alpha. But if I'm over here or over here, then I'm in the reject the null hypothesis region, and my probability, the p value, the p that I get back for probability will be less than the alpha value. So there are only two possible decisions. You either reject the null hypothesis or you fail to reject the null hypothesis. Reject the null hypothesis if the probability is less than alpha. Otherwise, fail to reject it. That's your decision. Then you're going to have to write a conclusion statement, and that's related to the problem. So you're going to come up with a sentence that is in context of the problem, that tells you what rejecting the null actually means. So like back over here, remember I said my null hypothesis is that the proportion of students who transfer is 50%. So rejecting that would mean we have evidence to believe the proportion of students that transfer is no longer 50%. So here's the dynamics, okay? So we're looking at that null hypothesis, and then we're taking our sample proportion, subtracting whatever our hypothesis value is here over the standard deviation to get the z-score, and comparing that to the z-critical or equivalently, looking to see if the probability of getting this z is less than alpha. If it is, then we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So we're going to work through two examples on the next video.